Imagine, billions of years ago, a universe that was vastly different from the one we know today. Back then, everything was compressed into an incredibly small and incredibly dense ball, no larger than the head of a pin. But this tiny point contained all the matter and energy that would eventually make up the entire universe. This was the universe before the Big Bang. And then, in a single moment, that tiny point exploded. The energy released in that explosion was so powerful that it created everything we know today. But where did this explosion come from? What caused the Big Bang? This is one of the biggest mysteries in all of science. Despite the many theories, scientists still don't know for sure what caused the Big Bang. The stars, the planets, the galaxies, the you, the me, all of it began with the Big Bang. Or did it? Ever since its launch, the James Webb Space Telescope has shown the universe in unprecedented detail. It has shown us portions of the universe that were previously buried beneath layers of dust. It has provided us with enhanced photographs of cosmic wonders that the Hubble Space Telescope once caught. It has revealed that the early universe functioned substantially differently than we thought. And it has now enabled astronomers to witness something that they are currently unable to explain. In a recent research conducted by the Webb telescope, astronomers spent 50 hours staring into the depths of the cosmos and uncovered something that has left them perplexed. Okay, so we all know how the Webb telescope discovered stars, developing during the universe's dark ages. Astronomers exploring the universe through telescopes spent 50 hours staring into the deepest portion of the cosmos, and guess what? They discovered some of the first galaxies to emerge more than 13 billion years ago. It is estimated that the universe is 13.8 billion years old. Capturing such a wide cosmic panorama, complete with the tiniest objects ever seen by humanity, is a remarkable feat. With its infrared detection skills, only Webb could have done it. However, what makes this interesting is that the data reveals these primordial galaxies emitted an extraordinary amount of energy into space, 10 times more than scientists had predicted. One of the crucial questions raised by this discovery is how these nascent galaxies achieved such high energy output. Scientists are now referring to this as the key question. Over billions of years, advanced computing simulations have attempted to mimic the history of the cosmos, including the production of stars, galaxies, and the organic building elements of life. None of these calculations, however, expected the extraordinary levels of UV energy that were measured. One possible explanation for this occurrence is the presence of young, highly powerful stars that generate vast amounts of energy, far exceeding the output of our own medium-sized sun. Alternatively, this ancient light could have been generated by supermassive black holes, which are hundreds of thousands to billions of times more massive than the sun, and are typically found at the centers of galaxies like our Milky Way. So which one is it? Peculiar black holes? Or humongous active stars? To answer the question, let's look at what the astronomers found whilst looking at the deepest part of the cosmos. Well, for starters, they identified 44 galaxies that likely formed within the first 500 million years of the universe's existence. Initially, the energy emitted by these galaxies was in the form of ultraviolet light, but it has since been stretched to infrared wavelengths. The discovery of these confusing facts, however, has raised more questions than answers, but it has also spurred excitement among experts. Most scientists now believe that supermassive black holes are to blame for the early light in the infant cosmos. But what this does is that it raises a very big question, possible the biggest we have asked so far. How did these supermassive black holes form in the first place? Because most black holes form from the remnants of a large star that dies in a supernova explosion, the existence of stars to form a black hole is crucial. Does it mean that there are stars even older than what we have found so far, with the help of Webb? Is our universe stranger than what we thought? For the latter, I'd say most definitely. In the foggy dawn of the universe, an object has emerged that has left astronomers in awe. Observations from the James Webb Space Telescope have revealed an active supermassive black hole 10 million times the mass of the Sun, one that is continuously growing as it slurps up stuff from the surrounding space. This is the earliest developing supermassive black hole observed so far, 570 million years after the Big Bang. However, scientists hope it won't retain the record for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY8p7, though since renamed Sears_1019. Its discovery could help with one of the biggest head-scratchers of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. We found the most distant active galactic nucleus AGN, and the most distant, earliest black hole we've ever found, said an astrophysicist associated with the finding. Scientists were initially looking at Sears-1019 as part of their work, investigating light produced by star formation in the very early universe. This light, known as Lyman alpha emission, is considered to be produced by star formation activity ionizing neutral hydrogen. The early universe was filled with a fog of neutral hydrogen, which prevented light from propagating. Light could only flow freely after this hydrogen was ionized. This epoch of reionization, as it is known, is not fully understood. We know it took place in the first billion years, after the Big Bang 13.8 billion years ago, but seeing that far into the early universe is really hard. Sears_1019 and a handful of other super-early galaxies are excellent targets for this research, because they're relatively bright. The galaxy was identified in Hubble data in 2015, and at the time, was the earliest, most distant galaxy observed. Subsequent observations confirmed its existence, but more detailed information remained elusive. The earliest light in the universe has shifted so far into the infrared part of the spectrum, due to the universe's expansion, that a powerful, dedicated infrared instrument like JWST is necessary to probe them. So, when JWST came along, Sears_1019, the brightest of the Hubble galaxies from this epoch, was an obvious target. The telescope stared at the galaxy for just 1 hour, with all 4 of its instruments, but returned a wealth of data. In the moment I was kind of like, wow, look at everything we can see with JWST. We've seen this whole portion of the spectrum of this galaxy, and any galaxies early on in the universe, we've never seen before, said astrophysicist Rebecca Lawson. I was just overwhelmed by the amount of information. But then she noticed something she wasn't quite expecting. Aside from the brightness of star formation, there was a broad emission feature typical of AGN. Things started to get intriguing when she reported it to several AGN researchers. In the early universe, a galaxy will typically emit either light from an AGN or light from star formation. To see both in the same galaxy was extremely unexpected. The black hole has an effect on the emission lines we detect, but the majority of the light in our photos is still dominated by the star-forming region of the galaxy. It is not as unexpected as you might believe that a supermassive black hole existed more than 13.2 billion years ago and was observed to expand. Much larger black holes have been detected in the early universe. Scientists still do not know how the black holes in those galaxies got to be so massive that early on in the universe. Only lately have we identified galaxies that formed only 300 million years after the Big Bang. These galaxies are large and intricate, and scientists all over the world were perplexed since, according to the standard model of cosmology, such galaxies could not exist so early on. These were first discovered as a sequence of fuzzy dots that were particularly bright and red. The 6 giant galaxies, which contain almost as many stars as the Milky Way, despite forming only 500 to 700 million years after the Big Bang, have been dubbed universe breakers by the team of astronomers that spotted them. That's because, if they are true, the discovery calls our entire concept of galaxy creation into doubt. To explain the appearance of such enormous galaxies so early to the beginning of time, scientists would have to re-examine core cosmological rules and their knowledge of how the first galaxies were seeded from minuscule clouds of stars and dust. The discovery of such massive galaxies so soon after the Big Bang suggests that the Dark Ages may not have been so dark after all, and that the universe may have been awash with star formation far earlier than we thought. Now, with the discovery of this black hole only some 500 million years after the birth of the universe, is a mystery in itself. The image of the early universe is shifting quicker than we thought. And, whether you like it or not, it is time to start over. The James Webb Space Telescope continues to push the boundaries of knowledge, delivering crucial insights into the secrets of the cosmos. As we wait for fresh findings, both answers and new questions, the Webb telescope remains at the vanguard of scientific discovery. So, would you like to travel to the other side of the universe, or stick with us here, at the edge of the universe? Until we meet again.